All right. Welcome to day 33. I was like, you know what? I was already planning on going live already, of course, and I was sitting here talking on the phone. Then I realized I had been talking about this a little bit, but I'm starting a shop for like coding themed products, and I just set up my TikTok shop. And the thing is, I'm starting with like a bunch of Valentine's Day items, and TikTok is doing like a shop promotion that stores can opt into for Valentine's Day. But the kicker is the specific campaign that I want to participate in or enter my items into. My items are due at midnight, and it's 9:30. So I was like, let me get off the phone and let me get my work done here, so that way I can pretty much spend the rest of the night. I can spend the rest of the night working on getting some stuff up in the shop. So, anyways, that's a whole little side thing. But look, you gotta diversify. You gotta diversify. That's kind of where I am. I'm an entrepreneur, really. So, essentially, I'm at a phase in my life where I'm like, I don't want everything to depend on development work, so to speak. And I also am trying to move out of trading time for money. So, with that being said, yeah, y'all have seen, probably most likely, a lot of people have seen like my jackets that I've made like vests and stuff for myself. So I do like a lot of custom um products. I don't even know if you're gonna be able to see this because it's got something brown in it. But see my little face here. Can I put some light through it? Hold on. Let's see. It's just something I was experimenting with, but you can see the design now. Ain't that cute? So it's basically a cross, but it says faith, right? And I did make these vinyl decals by hand. So that's one avenue. So I'm playing around with different ideas. I made some vests. I made like my Meta Deaf Girl like blue jean jacket. I made that by hand too. The stuff that's gonna go in my shop is not gonna be made by hand. The stuff that's going in my shop is gonna pretty much be just like t-shirts and hoodies and stuff like that people could just order anytime. I don't know though. I might have to put up some custom. I might have to put some custom in the shop. But I want people are gonna want to get their stuff by Valentine's Day because this is a Valentine's Day promotion. So that's the only thing. But anyways, that's neither here nor there. But that does give a little context to my priority today, my timing today, and kind of just being to the point on what it is that I need to get done tonight. So I figure I'm gonna go and get a little studying in. I am working on the vector search and embeddings course on Google Cloud Skills Boost. So we started that yesterday. So that's what I'm going to work on today. I'm over here taking notes on this side. I have started to use Obsidian to gather thoughts around different things I'm interested in researching. Even before I get into, even before I get into like, um, like I don't need to be in a PhD program to do research, you know what I mean? So there's things that I want to try even in the short term, but I've also just been kind of gathering thoughts around things that I'm interested in researching within AI. So that's pretty much what Obsidian is. So right now I'm learning about word embeddings and vector databases. So I'm going to try to give my brief description of it again until it's like very concise. So word embeddings are vector. It's like taking any type of data that you have and putting it in a vector format. Okay. And now once you have your data, each data piece in a vector format, then you store it in a vector database. And once you basically, if you are incorporating this into your process, you're going to get better performance out of your machine learning tasks. So that's kind of a little bit of of a spiel on it. But yeah, um, welcome in, y'all. I've been trying to give a little spiel at the beginning of at the beginning of the streams. so that we kind of know exactly what we're getting into, and especially for people that go watch the recording. Um, so welcome in, Queen Panda. I'm focused. I'm in a focused headspace and don't have audio right now, but wanted to give you support and love your AKA swag. Let's see. Thanks, Queen. Okay. Cyber work. Do they care about your GPA? Yes. 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 GPA is gonna matter, and GPA is gonna matter a lot for me because I want to go into like a top 10. I really would say top 10, top 20 school, but I want to go into a top 10 program. So I'm going to be competing with a lot of people. So it's not like I think you want to be a good all around candidate, but at the same time, you are competing, and it's highly competitive at that in that era or realm of schools. So it would be best for me to have as high of a GPA as possible. And one of the reasons that I am actually going to do a master's program is more so to like establish my educational practices, since it's been a while since I've been out of school, and also to make sure that I have like a good established GPA. So this is the program that I'm MS, yes, this is the program that I'm applying to for masters. And if you notice this picture right here, and this is the picture that's on my vision board. I couldn't help but like love everything about that picture, especially with me having a son, and I feel like my son would be about this age, considering me being on track for for graduating and everything. So this was like that hit me. But anywho, yeah, this is the program that I'm doing to prepare for PhD candidacy, both from a technical perspective to make sure that I have like a good solid competitive GPA, and also just to start getting some connections too, because Georgia Tech is a school I'm interested in, and Georgia Tech is also a school that a top 10 they're a top 10 CS program. So it's a lot of good reasons for this. Also, it's online, and I'm not really ready to go back to school in person yet. When it's time for me to put my baby in school, we'll be going in school, in person in school together, I think. Guess I'm never getting in any PhD with my 3.0. No, that's not true. That's not true at all. You can, but you have to, you just have to think about it. Now, it depends on what you want to do, and then you want to be a well-rounded applicant. So if you really do want to get into a PhD program, if that's something you really want to do, they're going to look at your GPA, just because being in academia, studying for your PhD, you have to go through your classes. You have to go through some really rigorous material. So of course they want to make sure that you're capable in that regard. But they also want to see if you have, like, for a PhD, they'll want to see if you have research experience. That'll be extremely important as well. So if you can find opportunities to do research, or getting into projects, or if you can kind of get some really good professional recommendations if you're already out of school or whatever, then that will go a long way too. And then it just depends, but the most important thing, from everything I know, from all the people that I have in my sphere who have done PhD programs as well, or who are advisors, the most important thing you're looking for is for a professor that wants you in their lab or wants you on their team. That's the biggest thing. Because you can have a 4.0, you could be a perfect candidate in every regard. And if the topic that you are researching doesn't align with anybody in the specific university you apply to, you're not going to get accepted. That's just it. Like, it's basically like saying, it's almost like, it's kind of like a job. It's like a job application. If I could be the best software engineer in the world, if I walk up to a company who does not hire software engineers, it don't really matter how good of a software engineer I am. If they don't have a job for me, they're going to have to turn me down. Time to raise up some professor. No, but for real. When I was still going to Wayne State, which is the school that I originally started at here in Detroit, I was getting into working with, I was in the mechanical engineering department, and I was getting into working with one of my mechanical engineering professors because he had an engine diagnostics lab. So I was undergrad, but I was reaching out to him. He was giving me opportunities to come into the lab and like actually, do some work with them and things like that. And even now, I believe that if I was interested in coming and, trying to come on board and do some projects in his lab, even if I'm not going to school there anymore, but if I wanted to come, and try to do some projects or whatever, I'm sure that it's something that we could work out. So it's kind of like that. Yeah, you should be trying to raise up the professors, so to speak, those that have research opportunities, or especially if they have a topic area that you're interested in. So when I was going into the engine diagnostics lab, I was less interested in like the mechanical side of engine diagnostics and more interested in how I could apply machine learning to some of the data that they had coming out of the lab. And in that case, those engineering professors that was running that lab, they didn't have very much programming experience in the lab. You know what I mean? They didn't have anybody with computer science background coming in and kind of combining those two together. So it was a lot of things that I could offer to them in that regard. Miss Steiner, welcome in. Is it bedtime? It's always bedtime. It's so funny because I be thinking about you now whenever I'm like, it's getting later and later. And I'm like, it be everybody's bedtime. Single professors in my area. No, for real. Like, that's not even a joke. How difficult is learning data science and machine learning? To me, it's just as difficult as any other like computer science field, I guess you could say. It depends on, it's well suited for my particular skill set, I guess you could say, because machine learning, the core, every computer science like discipline, every engineering discipline, it has an underlying foundation. So for example, when I was mechanical engineering, underlying foundations was like physics. We had something, trigonometry, like from math perspective, trigonometry, physics, calculus. Those were important for mechanical engineer. So for a machine learning, if you want to get down to the theory of it, it's based in like linear algebra, stuff like that. So that's really nice for me because I'm a math person. But if you just want to apply machine learning as a software engineer, you won't have to get into like the math and the algorithms of it. You would more so be looking at existing models and existing libraries and frameworks, and typically there's best practices that they're going to tell you. Even with this course that I'm going through right now, the reason why I'm looking at vector search and embeddings is because this is all already proven to be an efficient method for working with generative AI. And it also, this specific technique helps to combat one of the big issues we have with generative AI, which is called hallucinations, right? So hallucinations, if you're not familiar with it, hallucinations is when you talk to generative AI, you talk to a large language model, it has no concept of being like, hey, you know what, I'm actually not sure about that. It'll literally make up stuff sometimes, or it might it might mix different sources of information together, which essentially is still making up stuff. So, you know, me, I'm the only Jessica you gonna find probably. So if you was to say like ask a large language model about a specific person and they have a very unique name, it's either going to say, oh, I don't know that person, or it might give you some good information. But if you have a very common name, then you might have like this happened before. You might have a politician, and then you might have like a known like criminal or something like that. They both have the same name, and then the LLM is like basically merges their two their two backgrounds together and gives you misinformation. So I didn't have to come up with the idea of how to do vector search and embeddings, nor did I have to actually come up with my own method of creating embeddings from my data. Google actually has an established model that lets you go ahead and convert your data, and they also have vector databases. It just makes shit up. Yes, basically. I'm barely hanging on. I'm about to do this voiceover and finish editing this video. Okay, woo woo. I'm not a big time creator, but welcome in, Vizzy. Thank you. I can't tell which of y'all can hear me or not because, ads and whatnot. But I'm doing good tonight. In a good mood. I had a nap, okay? I had a nap. I had a 3-hour nap. It was great. It was so fantastic. Emo only chat. Uh-oh. Hold on. Let me see if I can do it for y'all. Did it work? I think it worked. Yeah. We hardly ever use emo only chat here, and I'm very fascinated by it. Oh man. I'm gonna give it like 2 more minutes of emo only. Just spam all the emotes. Show me some good tech emotes. Y'all got some good tech emotes? We got this one, but I think we need more. And we need some machine learning ones. Make me dab. Lordy Lord. All right, I'm gonna give 60 more seconds. What is this stinky glitch? Oh man. But yeah, I'm doing good today. I was just saying I basically realized that I'm starting to shop around like coding themed like swag and hoodies, t-shirts, that kind of stuff. So I started the TikTok shop, and I need to get my products up on the TikTok shop for a Valentine's Day promotion that's coming up. The Valentine's Day promotion is at it's going to be between the 5th and the 9th on TikTok. So I need to get my items that I want in that promotion into the shop by midnight tonight. And yeah, it's 9:22. So I'm gonna get some time in on the course that I'm taking here, and then I'm gonna go ahead and all right. I think our time has elapsed. But yeah, I'm gonna go ahead and get some time in on the course, and then I will spend like the next couple hours working on my TikTok shop so I can get some of my ideas in there. Here's one of the things I'm gonna do something like this. Where is that one design? Oh, you know what? I think I got it on my computer now. Where is it? Downloads. This one. I'm gonna do a concept like this one. I have some other ideas too, but I liked this one. I was just testing out Imagine because we got preview access for Imagine on Google Cloud. So I think this would be a cute idea. I'm gonna make it a little bit more tech though, like with some coloring on the syntax, like some syntax highlighting basically. But that's like the terminal, of course. So I think we need like the little prompts line, and then I have some other ideas too. So probably at 10 o'clock, my cutoff time for today is going to be at 10. So I have about 37 minutes. And then just so I can make that midnight deadline. Ooh, it really struggled with I'm just looking at this image. It really did struggle with the hoodie strings. But all things considered though, this is completely AI generated just by me saying, I think it was like a software engineering themes Valentine's hoodie. So it's really good, honestly. Her hair looks good. Her features look good. The hoodie looks good. It's just some little details. But Imagine isn't coming out of preview mode until, see this part right here. The texturing is off. But Imagine is still in preview mode. It doesn't come out of preview mode until the end of this quarter. So they have more time. But this is a good showing, honestly, compared to what Imagine 1 looks like. So yeah, let me know what y'all working on today, cause today we also for Beauty Go Go, that's the app I've been trying to get into beta, and we were able to successfully run like, it's literally 3 apps all communicating together. 3 users are a part of the process. So we were able to get some successful rounds of the user flow tested out today. So there's some things I have to work on there. So tomorrow I'll be working on that. But we got a lot of good testing in today, and I was very excited to see it in action. So we're ready to put paying users on the platform. What's the AI? You mean the one I was using for that? The one I used for that image? It's called Imagine, which is the one I showed y'all in Cloud Skills Boost. Not Cloud Skills Boost, Google Cloud Console. Somewhere here. This one. This is Imagine, but Imagine is in preview mode. So you wouldn't be able to see. I like this too, with like a quote. I'm gonna download this one. I'm gonna probably do something like this. No image to export. Download. I'm gonna do something like this with like some type of quote in the heart. I think that would be cute. But this is you won't have access to this unless you had like special preview access. But it's similar to, this one is similar to Midjourney. I haven't played around with Midjourney in a minute. We have Midjourney in the Discord server though, for people that do have Midjourney access. There's an AI art channel, I think. I should give them feedback since that's probably very helpful at this point. Oh, let me tell y'all something I found out about, because we kind of talking AI, but also business, AI for businesses. It's called Let's do this, like AI video mock-ups. I can't even remember the name of it. Place it, place it, place it. Yep, yep, yep. I want y'all to know about this. I found out about this, and it's like kind of a game changer. If you are doing like any type of mock-ups, they have these are the phone mock-ups, but let me see, TikTok mock-ups for apparel videos. Would that be a good one? Hoodies. Let's just do hoodies. So these are the pictures, but they have video. Oh no, this is not. Is this it? There's video mock-ups too. That's what I'm looking for. Print on demand. So I think most people, well, maybe not all people, but a lot of people are familiar with these like this concept of mock-ups. But I found a site. I think it is Place It. Place It video mock-ups. Okay, here's the website. No, did Envato buy this or what? Because this was not. That's promo videos, TikTok videos. I'm trying to show. Yeah, so see how they basically have people wearing like the shirts and stuff like that. So then you could put a mock-up on a live video. And that's more so better for something like a TikTok shop where you might not have people to wear the products at the beginning if you do like print on demand or something like that. But this is not like a good example because they should have showed it on somebody. Hold on, let me see if I can find it. Jacked up part is, I swore I saved this. I might have it on one tab somewhere. Oh yeah, see. Yeah, she was actually doing a video. Okay. So I could put, if this was appropriate for like my shop branding, basically, then you could have like a person wearing the product, the mock-up of the product, instead of just having the static mock-up. So that's a good one. Midjourney is great. Midjourney is really, really, Midjourney is fantastic. I already know for sure. I just haven't played with it in a minute. I need to buy a subscription to Midjourney because if I'm not mistaken, when I first started using Midjourney, it was like in free preview, and now I need to buy a membership so I can get to using it again. See, like that's a good, oh dang, why won't they show the video from here? Okay, see, like that's a good little, I would see, you could use something like that, and especially for something, if you have like anime theme, that's a good one. Hers is real boho. That one's for a bag. Oh no, not the not the NPCs. Not the NPCs. Did y'all see this era when we had like the TikTok NPCs? Because I was just having that conversation with my sister. I don't like the, I mean, maybe I would because it's viral. That shit kind of sells. I like her, but I need like I need a black girl. Can I get a black girl, please? I don't think I can. Oh, I can. Wow. I was literally about to say, I don't think I can filter because I mean, I don't want. It's no shade to nobody. I want some of my coding products on like I want to. Yes, 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 yes. I need some black girls wearing coding merch. Also, not just That's the whole point. Okay, okay, okay. Huh. So, anyways, I don't know who needed to know about this, but this is a thing. And I am definitely about to do this for my Valentine's items because I'm going to have to order. I'm going to have to order. I'm going to have to do an order of them so that way I can actually. Oh, she can wear multiple items, but I don't like that blue. I like this one out. I'm gonna have to wait for my my items to come in to have them in hand to be able to like make videos and stuff. This is so I don't know. I don't know who needed to see this, but we out here, okay? So I'm leaving that up. We got still about 30 minutes, so that's good. Basically where I left off, I don't want the okay, I'm gonna leave it here. I'm gonna leave that there. I'm gonna show y'all my shop tomorrow. But let me know if you have ideas about something you would wear that's coding themed, like a Valentine's Day coding themed design, because I'm coming up with design ideas and I'm gonna put those together. So I like the one with the heart with the I like the heart with the code like command line. And I'm trying to remember where I put the rest of my ideas because I have been generating different ideas. And I use ChatGPT for that kind of stuff too. The other thing I've been thinking about making is some I want to make some affirmation cards for software engineers. I think that would be cool. Especially if you struggle with like imposter syndrome, which a lot of us do, including myself, highly. So that's the kind of stuff that would be in the that will be in the shop. I want like my my MacBook is my Valentine type. I want some stuff like that. Okay, so I'm gonna restart this video. This video, I was kind of I wasn't dozing, but I was kind of drifting mentally when I got here. So this one is 7 minutes. This one is
the first technology you explore is
so 7, 14, 21.
Having grasped the concepts of you learned how to build vector.
So this is good. 1, 2, 3. I'm gonna go back to embeddings and I'm gonna watch these videos. I think I'll have time to watch the videos and I possibly can pass my quiz. I'm gonna do the lab tomorrow. And that's just because I want to get my shop up because your girl trying to generate some passive income. Okay, that's real life. Create a vector search.
Let's examine the next core technology, vector search. Now that the embeddings are prepared, the list of terms is ready.
Go back to embeddings.
The next step is to create. The first technology you explore is embeddings, which address the first issue of encoding data into a representation that captures semantic meaning. Although multimodal data, including text, images, audio, video, and code, can be converted to vector embeddings, let's use text embeddings as an example. The challenge is, again, how to represent text in a numeric format while retaining its meaning. This challenge can be further divided into two subproblems. One, how do you turn text to numbers that retain meaning? For example, the numbers should indicate relationships between words such as similarity and difference. And two, how do you turn text into numbers that can be fed into a machine learning model? For example, a machine learning model normally requires the input to be a relatively dense matrix or vectors. An overly sparse matrix might lead to model overfitting. Any ideas for how to resolve this? Let's talk about text representation techniques to set the stage for vector embeddings, from simple approaches to state-of-the-art techniques including basic vectorization and word embeddings. Let's start with the basic vectorization techniques. For example, an intuitive technique called one-hot encoding. With this technique, you one-hot encode each word in your vocabulary. Consider the sentence, "A dog is chasing a person." After tokenization, which divides the sentence into smaller digestible units, and pre-processing, which leaves the root in keywords, the sentence can be represented by 3 words: dog, chase, person. Assume you have a vocabulary that includes 6 words: dog, chase, person, my, cat, and run. You then place a 1 to the position that corresponds to the word and zeros to the rest of the positions. By conducting one-hot encoding, you tune each word to a vector and convert the sentence, "A dog is chasing a person," into a matrix that a machine learning model ingests. What are the benefits of one-hot encoding? It's intuitive to understand and easy to implement. However, let's also acknowledge the disadvantages. Recall the 2 sub-challenges of text representation. One-hot encoding has 2 main issues among others. First of all, this representation does not convey any relationships between words. Second, the generated matrix is high-dimensional and sparse, which leads to overfitting of the machine learning model. What does it mean? The dimensions of each vector depend on the size of the vocabulary, which can easily be tens of thousands. Also, most of the values of each vector are zeros, which means that this is a super sparse representation. Imagine you have 10,000 words in the vocabulary. You can create a matrix where 99.99% of the elements are 0. This results in a large sparse matrix, which can lead to computational waste and model overfitting. To solve these problems, you explore a new approach called word embeddings. Let's start with intuition to see how you can encode text to numbers that convey meanings using word embeddings. Let's ask the question, how would you describe a dog? How about their breeds? Physical stats such as height and weight, hair color and length, relationship to you such as a family member or neighbor's dog, their behaviors like bark or quiet. You get the idea. You can easily think of at least 20 different dimensions to describe a dog. How do you describe a word then? For example, the word queen. How do you convey the nature of it, its origin, and the sense of belonging, excitement, and trust associated with this word by using quantitative measurements? You can use dimensions, and in math, a vector space. You can now generate an idea. How about representing a word in a vector space with dimensions to describe its properties? Not only that, you want the distance between the words to indicate the semantic similarities between them. For example, queen and king are close to each other but far from apple. Additionally, you want this representation to capture the analogy between words. For example, the distance between king and queen is similar to the distance between man and woman. Now you have king minus man plus woman equals queen. Isn't it amazing to play with words in the same way you play with numbers? Word embedding is a technique to encode text into meaningful vectors. The technique lets you represent text with low-dimensional dense vectors. You don't need the vector size as big as 20,000, like in one-hot encoding. Instead, you have between single-digit dimensions for small datasets and 4-digit dimensions for large datasets. Each dimension is supposed to capture a feature of a word. A higher dimensional embedding captures detailed relationships between words. However, it takes more data and resources to train. Additionally, you don't have sparse vectors anymore. The cells of a vector in word embeddings normally contain values. More importantly, the vectors capture the relationships between words where similar words have a similar encoding. Word embedding is sometimes referred to as distributed representation, indicating that the meanings of a word are distributed across dimensions. You now understand the idea of word embedding. But how can you develop such an encoding system to convert text to vectors? Instead of manually specifying the values for the embedding, you train a neural network to learn those numbers. Neural networks have been used to train word embeddings, which include a variety of algorithms or models, such as the popular Word2Vec by Google, GloV by Stanford, and FastText by Facebook. To learn more about the different algorithms used to train neural networks to generate word embeddings, please refer to the module on text representation in the course titled Natural Language Processing on Google Cloud, which is listed in the reading. Training on a large corpus typically requires a great deal of computational resources. Fortunately, you do not have to train the neural networks yourself. Instead, you can use pre-trained embedding models by calling APIs. Consider the following code example to see how simple it is to use embedding APIs. After importing the embedding libraries, you first need to specify the name of the pre-trained embedding model that you want to use, such as text embedding Gecko and multimodal embedding, both provided by Google. Second, you need to define the text input. Third, you need to get the embeddings. You can find more coding examples in the following demo and the hands-on lab. You have examined text embeddings. You can also use the same approach to convert other media, such as images, to embeddings. This way, you can find that the text, dog, and the image of a dog are located near each other in the same vector space. Let's examine the next core technology, vector search. Now that the embeddings are prepared, the list of terms is ready. The next step is to create a book index. In vector search, the challenge is how to index the vector space to enable fast and efficient search. However, fast and scalable vector search isn't easy. It contains two major challenges, among others. How can you measure the distance between vectors? How can you search vectors in a fast and scalable way? Let's address the first issue. How can you measure the distance between vectors? Imagine you have a multi-dimensional vector space where visual detection is impossible. How do you know that king and queen are closer to each other than they are to Apple? When building vector search on Google Cloud, you can choose from 4 widely used metrics to measure the distance between vectors. The selection depends on various factors, with the embedding model being one of the primary considerations. The first 2 metrics, Manhattan and Euclidean distance, measure the distance between the endpoints of the vectors. The third metric, cosine distance, measures the angle between 2 vectors and defines the vector similarity in terms of directions. The fourth metric, dot product distance, considers the similarity in terms of both the direction and the magnitude of 2 vectors. First is Manhattan distance, also known as the L1 distance. Manhattan distance calculates the distance between 2 points in a grid-like pattern, like the streets of Manhattan in New York City. It is defined as the sum of the absolute differences between the corresponding coordinates of the 2 points, where one can only move along one axis at a time. Next is Euclidean distance, also known as the L2 or square distance. Euclidean distance calculates the shortest distance between 2 points in a straight line. It is defined as the square root of the sum of the square differences between the corresponding coordinates of the 2 points. Third is cosine distance, which measures the similarity of 2 vectors in terms of their direction. Cosine similarity is calculated by taking the cosine of the angle between the 2 vectors, where 0 indicates that the vectors are completely aligned, and 1 indicates that they are completely orthogonal. Last is the dot product distance, also known as the inner product distance. It is based on the projection of one vector onto another. It considers the similarity between 2 vectors in terms of both their direction and magnitude. Once you know how to measure the distance between two vectors, the next challenge is to efficiently find the similar vectors in the vast vector space. Two search algorithms have seen extensive use: brute force, which is based on an accurate, exhaustive search approach, and TRIA, which relies on an approximate tree search algorithm. TRIA stands for shallow tree and asymmetric caching. It is widely used in a production environment. The brute force algorithm typically consists of 3 steps. Step 1. Calculate the distances from the query to the other vectors in the vector space. Step 2. Sort all distances. Step 3. Find the top k nearest vectors. Because the size of the database can easily be in the millions or even billions, exhaustive search is impractical, and the brute force algorithm becomes a computational bottleneck. The TRIA algorithm accelerates search by using an approximate search technique called ANN, or approximate nearest neighbor. ANN enables fast and scalable search with billions of embeddings by dividing the search space into multiple spaces, indexing the spaces using a tree structure, and trading some accuracy for a significant speedup over brute force search. In 2020, Google Research introduced SCAN, which means Scalable Approximate Nearest Neighbor, a new ANN algorithm. SCAN is the foundation for many Google services, including Google Search, YouTube, and its recommendation system. It is considered one of the best ANN algorithms in the industry, both in terms of accuracy and speed. You can check the reading list for more information. How does SCAN enable fast and scalable vector search? Let's uncover the secrets of Google Search. Consider the brute force complexity, which is O of n times d, where n is the number of vectors and d is the number of dimensions. To enhance vector search performance, you need to apply a combination of critical techniques. Reduce the search space, also known as space pruning, and compress the vector size using data quantization. Also, you need to increase ranking efficiency by integrating business logics. To reduce the search space, SCAN uses a multi-level tree search for space pruning. The first step is to divide the vector space into hierarchical partitions, as shown on the right. A search tree is then constructed to represent the structure, as shown on the left. Each node in the tree represents the centroid, the center point, of a partition. Next, you select the partitions closest to the query. The red squares represent vector spaces that are close to the query, while the yellow squares indicate the spaces that are far from the query and will then be pruned. You start by searching from the root node, the query, then moving to the branches, the partitions, and finally to the leaves, the subpartitions. During this process, you prune the tree to eliminate irrelevant search space. Last, you search for approximate data points within leaves, the most relevant subpartitions. The second technique is data quantization. Data quantization is used to compress data points to save space and reduce indexing time. For example, data quantization can be used to compress a 9-dimensional vector from 9 floats to 12 bits. The third technique is to incorporate business logic to retrieve only the data that is relevant. For example, you can use a filter to find resorts in the United States and dresses in the color red. From a technical perspective, this is known as restricting the search to a portion of the dataset. SCAN, Scalable Approximate Nearest Neighbor, is a combination of these techniques. Vertex AI Vector Search is built on a similar, more advanced version of SCAN. Vertex AI Vector Search provides a fully managed similarity vector search service. It was launched in 2021 under the name Matching Engine. Powered by SCAN and Vertex AI, the unified AI development platform, vector search is 30 to 50% less expensive than comparable services while maintaining fast searching, lower latencies, and scaling to billions of vectors. Having grasped the concepts of embeddings and vector search, you can now build a search engine by using the vector search service on Google Cloud. Vector search is now available for developers on Vertex AI, Google's unified AI development platform. Vertex AI is a fully managed service that is tightly integrated with Google Cloud's other services, such as BigQuery, embedding APIs, and MLOps, machine learning operations. This makes it easy to run queries and build indexes. Vector search provides excellent performance with high scalability and reliability, which makes it a good fit for Google-scale enterprise services. You can quickly create a production machine learning pipeline from data extraction, embedding generation, index creation, to endpoint deployment. There are 3 ways to set up your point deployment. There are 3 ways to set up your own vector search project and interact with vector search on Google Cloud. No code, using the user interface UI in the Vertex AI console on Google Cloud. Code-based, using APIs for pre-trained embeddings and vector search with Vertex AI notebooks, and minimum code using the command line with G-Cloud. G-Cloud offers limited functionality for creating and monitoring vector search. In this lesson, you focus on no-code UI and code-based APIs with notebooks. You can use APIs to build a vector search pipeline and the UI for experimenting and monitoring. Navigate to Vector Search of Vertex AI on Google Cloud. It's currently under the Deploy and Use tab. Please be aware that the UI might change as AI tools and technologies rapidly evolve. There are 2 menus. Indexes, where you can create and deploy a new index. Index endpoints, where you can run queries and monitor an index. Let's walk through how to create a new index. After providing a name, description, and region, you must define the vector data source. You are not restricted to using Google models to generate embeddings. You can use any model on the market. However, the generated vectors must be stored on Google Cloud for the subsequent index creation. Next is to determine the search algorithm. Triad is the default vector search algorithm, based on ANN, approximate nearest neighbor. It is fast and scalable and used in a production environment. Brute force is the other option. Based on a linear search, it is straightforward but less performant, especially when the data size becomes large. Brute force is more commonly used during development. You then instruct vector search with the dimensions of your embeddings, recall the embedding section from the earlier lesson, and approximate number of neighbors, recall the concept from explaining ANN. Next is to decide if you need to retrieve the query result with batch or stream. Finally, you can decide the shard size. Index data is divided in equal parts to be processed, which are called shards. To learn more about the types of shard sizes available and their corresponding prices, see the pricing page linked in the reading list. In addition to the basic setup options, you can also define some advanced options, such as the distance measure type. As you might recall from the previous lesson, you have 4 choices: Euclidean or L2 distance, Manhattan or L1 distance, cosine distance, and dot product distance. Dot product distance is the default and recommended metric for measuring vector distance. After you click Create, you should see that the index creation is in progress. It's usually very fast, taking less than 10 minutes depending on the data size. Once the index is created, you can deploy it to an endpoint by clicking the index name. Now the endpoint is ready, you can run queries or monitor the endpoint during production. Note that you can code all these options with Vertex AI notebooks and do even more to manage the pipeline. Let's look at an example. Assume you are a data scientist and would like to improve the customer searching experience and help them find similar items. First, you get embeddings for each item. Next, build an index on vector search with the embeddings. And last, you can run a query on vector search to find similar items by their names. Let's explore how this works. The BigQuery table for items such as pants and socks is shown here. BigQuery is the primary data warehouse product on Google Cloud. You can easily get text embeddings in BigQuery by using the ML embed text function. Although the process is straightforward, the results are cutting edge. The LLM-powered text embeddings are carefully organized in the embedding space with human-level intelligence and common sense. You then export the embeddings to a JSON file and store them on cloud storage. Each embedding has 768 dimensions. Note that the number of dimensions is a hyperparameter that you can specify when you call the embedding API. Afterward, create an index by invoking the vector search APIs. You can designate the search algorithm, which is Triad in the demo. Establish the cloud storage address of the JSON file, and include parameters like the dimensions, number of items to retrieve, and similarity measurement type. Google provides a rapid indexing service, which only takes a few minutes to index 3-digit megabytes. The final step is to deploy the index to an endpoint. The endpoint receives query requests from the front end and executes the vector search. The vector search engine is now ready to serve. To begin, provide the embedding of an item to the search engine. In a matter of milliseconds, you will receive a list of similar items. Please note that this is not a keyword search, but a semantic search. This means that the search engine understands the meaning of the search item and finds the closest information. This can provide a much better user experience for exploring and finding relevant items. Vector search is also very easy to use. You can do it with just a few clicks or simple codings.
My brain is just like in
You
full
learned
wow
how to build
mode.
vector search on Google.
Okay, this is the last part. Retrieval augmented generation. This is the part that I'm still kind of like, how do I get the concept of using this, but I want to see, this is what I'm really trying to understand, especially over the next couple of days with the labs and stuff. So I'm looking forward to the lab. But with the retrieval augmented generation for large language models, one of the big issues is it's all about context. So hallucinations is a problem in and of itself, but even if the model was perfect at telling you certain information, most of the time the model's not going to know or have the best information about your specific business. So both of those situations benefits from this concept of RAG, retrieval augmented generation. So give the language model the ability to look up relevant data, to look up, more info, get more context basically before it responds. And I've been wanting to put this into practice. So this last part is only like this video is like only about 6 minutes or so. So this is going to be the last thing I probably look at tonight. But yeah, I think it'll even be good too, because I'm going to let you have to let stuff, stew in your brain. So tomorrow, after I've been able to like sleep on this, I think I'm going to be excited. I'm trying to think of like, what projects would I like to build that can kind of put this into practice. So that's kind of where my mind is going with this right now. I'm just trying to think of what I would like to do with it, just so I can solidify it a little bit more. I do like the labs and everything. The only thing about it is, they're very guided. So I think even the next step after doing a bunch of the labs that I'm doing is to build a project, essentially from scratch, just so that I can know I'm able to go through this process and actually get some type of vector search into into production without without all the hand holding, if that makes sense.
Google Cloud. You learned how to build vector search on Google Cloud. Before we conclude, let's look at an exciting application of vector search in solving LLM hallucination problem with RAG. Vector search has a variety of applications. In addition to search, it can be used for personalization, trust, and safety. One recent application is to use vector search to address the hallucination problem of large language models. You might find yourself in a situation where the LLM, such as a chatbot, provides you with an entirely incorrect response. For example, the chatbot recommends eating yellow raspberries, which do not exist. This issue is known as the grounding problem, or LLM hallucination. LLMs can only understand the information they were trained on. This means that they might not be aware of your business's proprietary or domain-specific data. Also, they do not have access to real-time information. To make matters worse, LLMs only understand the information that is explicitly given to them in the prompt. In other words, they often assume that the prompt is true. They also do not have the ability to ask for more context information. Ultimately, an LLM does not know anything outside of what it was trained on, and it cannot truly know if that information is accurate. Hallucination is a major problem with LLMs. Common solutions to this problem include fine-tuning. This is an expensive process that requires a large amount of data and computing power. Human review. This is also an expensive and time-consuming process and is not always possible to catch all of the hallucinations. And prompt engineering. This approach can help to reduce hallucinations, but it is limited by the existing knowledge of the LLM. How about using vector search to provide additional real-time fact checks for LLMs? Vector search can be used to feed the LLM with relevant context in real time. The architecture to accomplish this process is called RAG, which stands for Retrieval Augmented Generation. To do this, you take the input prompt, query the real-time information using vector search, retrieve the top results, and append them to the original prompt. You then pass this augmented prompt with real-time context information to the LLM. Now the LLM has not only the original user query, but also additional information that it can use to answer the query. When you combine the search capability with the verification ability to ensure the freshness and the accuracy of data, the search becomes more reliable and trustworthy. Let's look at a use case of utilizing RAG to create a sophisticated chatbot. A user communicates with the chatbot through a text-based interface to inquire topics covered in Google research papers. However, the challenge is that LLMs cannot accurately memorize hundreds of documents. One approach is to use the RAG model, which enables the LLM to conduct a vector search to identify relevant papers. The LLM generates a summarized response to the question after reading the papers. The RAG model eliminates the need to train the LLM to memorize everything, which helps reduce the risk of hallucinations.
They just gave me my
This
idea.
is the prompt used in a RAG sample code. It contains the question from the user, the instructions for the LLM, such as use only the search results and do not make up an answer, and the papers retrieved through vector search. The RAG system can engage in conversations like this one, using knowledge gained through vector search to respond to questions. A quick recap of using vector search in RAG. Grounding occurs when the LLM doesn't have enough information to accurately complete a request. The LLM can only understand its training data and any prompt information. Sometimes the LLM might hallucinate, make up data to answer prompts. Retrieval augmented generation is the process of injecting additional supporting information into a prompt. Vector search helps RAG by adding supporting context and quickly searching relevant information in real time. Now it's time for practice. In this lab, you build a small-sized search engine by using vector search and text embeddings. Specifically, you quickly query Stack Overflow by asking coding questions like how can you shuffle rows in SQL? The search engine performs a text search on 8 million questions posted on Stack Overflow. This lab consists of 3 steps. First, you generate embeddings for your data. Then, you create a vector search index and deploy it. And lastly, you run a query. By the end of this lab, you will be prepared to use vector search to find similar items in your data. In this course, you learned that embeddings provide a new standard for representing business data, essential for the next generation user experience. Additionally, vector search plays a crucial role in managing and searching billions of embeddings within milliseconds. Vector search with Vertex AI offers scalable, reliable, production-quality vector search technology that powers many Google services. It is user-friendly and easy to get started, as demonstrated in the demos. Lastly, you saw how you can build a RAG system with vector search to solve the LLM hallucination problem. We hope you enjoyed this course. Be sure to check out other Google Cloud courses for continued learning.
All right, so I'm going to say 10 out of 10 to recommend. I like that. I like the course. This is really good information too. So they did give me my idea for my actual project. So I'm thinking about I think it's good that they're going to do the Stack Overflow example. That was the example. That was one of the examples that they were giving when they were um, going through this material during the workshop. So it's also very relevant to what I think I'm going to do. My plan for a practical project is actually to see if I can incorporate this into our chatbot, because I already wanted to get the nursery bot integrated with some type of LLM. And now I'm like, oh, that would be perfect actually. So what I'm thinking about is um, I'll probably end up having to jump back into the nursery bot code and start to figure out how we can set that up to where it has access and can, basically become an AI agent. And then which kind of data do we want to give it access to for RAG, and Stack Overflow will probably be a really good one to give it access to. I have to look and see after we do the lab, but I do know that in Google Cloud Console, one of the main reasons that they're able to use the Stack Overflow data for that example is because there there are large data sets that they have, like large public data sets in Google Cloud console, and the Stack Overflow data set I think is one of them. So that would actually be a perfect integration for the chatbot. Show. Um, I think that's where I'm gonna go with it. But one step at a time, one step at a time. So I'm gonna start. I'm gonna start with the lab tomorrow, and then once I finish the lab, I think that'll give me a much better idea of what modifications I'm gonna have to make to the chatbot in order to kind of integrate those together. So that's my thought process. And oh, I wonder if I could pass my quiz yet. Let's see, it's 7 questions. What is the main benefit? Oh, I only got 10 minutes. What is the main benefit of using vector search in the main benefit of using vector search in retrieval augmented generation to address LLM grounding? It allows real-time information for fact checking, eliminates the need for human review, reduces computational cost, improves the LLM's ability to understand and respond. The main benefit. I'm gonna come back to that one because most of these are actually right, but all right. So, which of the following is correct to compare between vector search and traditional? Vector search is faster. Vector search is limited to text. Is limited to vector search addresses semantic similarity and is good at solving ambiguous queries. Where should give us good at solving process. I would say it's not about speed, it's more about semantic similarity versus precise queries. The main purpose of using distance metrics like dot product measure the distance between vectors in terms of semantic similarity. Indexing, not generating new vectors, search for top 3 nearest neighbors. Two main technical challenges that need to be addressed in order to implement vector search effectively. Effective vector search. The distance between the vectors. Hallucination and grounding, encoding and indexing, efficiency and personalization, or user adoption and cost. Encoding and indexing. Oh, in order to implement, yeah. So in order to implement vector search, you need encoding and indexing. Those are prior steps. Two main techniques used by Scan to improve search. Pruning and quantization. Yeah, pruning and quantization. The general process to build a search application by using Vertex is to embed, index, and search. Process of encoding data into vectors is embedding. Generating embeddings. The main benefit of vector search. Oh, the main benefit of the search part, not RAG. The main benefit of the actual vector search is it. Would I say it improves the LLM's ability to understand and respond to complex prompts. It allows the LLM to access real-time information. I kind of want to go with this one. I'm torn between these two. But I feel like responding to the prompts and responding to complex prompts is not really what vector search is about. That's really more so the LLM itself. The only thing that throws me off about this is the quote-unquote real-time information. It's not necessarily real-time. It's also domain-specific information. But let's see. I answered all my questions. So, oh my God. Okay, I got 100. Yay. Okay, so at least I finished my quiz. And then this is the reading list. They said that they were going to put the NLP course and the text representation module on the reading list. So at least I know these are here. I'm going to download it. I need somewhere else to put it. AI, a new folder. Call it, what should I call it? New GenAI. Because I have some other documents other reading lists that I need to probably reorganize. I think I have them in my downloads though. So here's what I think we should do today. I was kind of peeking around to see what's happening, and we're going to go and raid Cyber Cow Studios tonight. It looks like they're working on some game dev, and also it's a group, they're pairing, so that should be exciting. So I want y'all to go and say hi to them. This is my first time checking out their stream as well, and so I'll probably hang in the chat while I get my stuff done. So I'll see y'all tomorrow. I'm gonna do the lab for this tomorrow. We'll be doing some machine learning, hopefully some machine learning integration into the chatbot. So hopefully y'all will come back for that. Otherwise, I hope you have a happy Saturday, and I'll see y'all in the next stream. Bye bye.